Hello, friends. Welcome back to Bratati Science Class. I am Bratati. Hope all of you are doing extremely great. And let's have a wonderful session today. Some natural phenomena. So, when we are talking about phenomena, and that's too natural, it's something God's creation. It's not in our hand. If we look in our surroundings, there are so many things where we don't have any hands, right? Like if it rains, or whether it's lightning, thunder, earthquake, tsunami, and many more, right? So, what is in our hand? We can concentrate like deforestation is causing by the human needs. So, we can plant more trees to save our Mother Earth. That's in our hand. So, I hope you are aligned with today's topic, which is some natural phenomena, chapter number 12 of Class 8 Science. So, are you ready to start? All right. So, as we were talking about the last class, you have seen that we were talking about charge and electricity, isn't it? So, we know what are the charges. So, if we look at our surrounding, all the objects, whether it's a comb, whether it's my mouse, whether it's my pen, so all the objects, even we are made up of small molecules, and the smallest part of the molecule we call it as atom. Every atom has positive charge, neutral charge, and negative charge. So let's begin. So you can see my screen. Okay, so here basically I want to show this is the atom structure. This is how it looks. You can see in the middle, this is called the center of the atom, which is called nucleus. The nucleus has the proton P, that is the positive charge, P plus. Also the neutral charge, that is N0, which is called neutron. So proton and neutron, these two are making the nucleus of the atom. That is the center of the atom, and the negative charge electron is freely revolving around the nucleus. Okay, that is the negative charge. So this is the structure of an atom. As you can see, the nucleus part, that is the concentrated part, is consists of the proton and the neutron, but the negative charge is revolving around. So when two objects come closer to each other, any two objects it can be, when two objects come close to each other and we do a friction on this, and then we can conduct, or we can keep these two objects in touch with each other, or rubbing against each other, that is causing a friction, then it might be possible that the electron from the outer surface will jump to the another object. So the object which is donating the electron, it's actually getting positive charge because it is releasing the negative charge. And the object which is receiving the electron, it's becoming negatively charged. So I think it's clear. So the electron donor, basically the electron donor, we call them as a positive charge. And if it is electron receiver, the object is becoming negative in charge, right? Okay. So now, as we know the magnetic properties, in that we have seen the like poles will repel each other and the opposite pole will attract to each other. So let's see what is happening. So I will be showing this now. I have dry hair because I have shampooed my hair, and this is the comb. Basically, what I will do, this is one object. I will take my dry hair, and this is another object. So I will be actually rubbing the comb against my hair, the dry hair. So what I'm doing, when I'm causing the rubbing, it's actually causing the friction. Okay. So when it's causing the friction, the charge is being generated, or the charge is being coming to this comb, right? So this is when I'm rubbing, or when we are doing the friction, the charge is there. Now you can see there are the small pieces of paper, and I'm bringing my charged comb here. So the piece of papers, those are actually neutrally charged, right? So there is no charge because proton electron are same in number, so they are the neutral charge. We may consider that there is no charge, but when I'm bringing charged comb, okay, so this proves that, as you know, that any charged body will attract a neutral body. Okay, and then we have the second experiment, the second activity we can do it. Please do it at home so that you can see on your own. So for that, what I need, I have taken a piece of cloth. You can take any cloth, a piece of cloth that is available at your home. It can be silk cloth, it can be nylon. Now I'm going to keep it, and what I have taken, two balloons. See, initially there is no charge in this. These are the objects with no charge. Now what I will create the friction, two same side, and then how much is possible, I will rub the balloon against the cloth to create charge in it. So as I am causing the friction, from the cloth, the negative charge of the free electron is passing to the balloon. And that part is actually, when they are being charged, you can see, can you see these balloons are not coming close to each other, rather they are repelling. Okay, yeah, the battery is not holding the balloons. Instead, you can just hold them in a thread and a rod. So in a rod and the thread, if you hold these two balloons, you can see easily that they are similar charges. They are repelling to each other. Now, how can we prove that these two are the similar charges? See, here the repulsion is completely seen. So they are going away from each other, not together. All right, so why I'm talking about that these are the negative charges. As you have seen that the electron is moving, the negative charge is moving around the atom. Okay. Basically, this cloth is having the positive charge and the negative charge. The positive charge is inside the nucleus, but the negative charge is just moving around it. And when this neutral charge body I bring together, so what happened? The charge transferred to this neutral body. So as the electron moves to this, so it becomes negative because it is the electron receiver. We say this is the negatively charged, and both the balloons we have done the same thing. So both the balloons are now negative charge, similar charge which repel to each other. So we have seen when we are taking this together, they are not being attracted, rather they are repulsing. All right, so rather they are repulsing. I hope that proves that was enough. So first examples or first activity, we have seen that the pieces of paper which was actually neutral charged, when I put the comb, the charged comb near the pieces of paper, it was getting attracted. So that is the first activity. And the second activity, we have seen that the similar charges will repel each other. Rather the positive and the negative charge will attract to each other. So now there is this is called the laws of electrostatic attraction. That is, the like charges will repel like the magnetic property, and the unlike charges will attract each other. Okay, so now we are moving to the device of the instrument that detects the simple present, even the very minute presence of the electric charge in a body. Okay, so it's easy to make at home. You need a glass jar, the clear glass jar. You need metal. It can be brass, it can be any other easily available metal in your shop and budget friendly, that goes according to your budget. You need an insulator and aluminum foil, because we can take gold leaf and all for the laboratory experiment, but at home if you want to make the electroscope, it's enough to have a metal disc, the same metal rod. You need insulator. It can be a rubber cork, it can be any stopper of the bottle. Okay, so that you can take as an insulator. You can create a hole, and through it the brass rod or any other metal rod will pass. On the top there will be a disc, a plate kind of thing. At the end of the rod there will be the two aluminum strips. That's it, your metal is ready. Okay, your electroscope is ready, but we need the aluminum foil or some other metal foil there in this part, which will be earth to ground. We will be talking about earthing in the next topic, what is earthing. But make sure that you need aluminum foil to pass the electricity or the charge through another wire, and that wire will be grounded. So that any excess charges will be grounded. It will not give any electric shock. Now let's see what can we do and how to detect the presence of a minute amount of the electricity or the charge in any object or any body. So what basically we will do, we will bring any rod or metal that is suppose positively charged. If it is positively charged, for example, if it is positively charged, so this part will be the negative charge and this part will be the positive charge. So as we know that the opposite opposite charges will be attracted. So the nearby charges is the opposite one, and the far away in the aluminium foil, we can see it is the similar charge. Now similar charge repels each other. So what we will see, these aluminium foils, they will move both sides. They will move away to each other, repel, because it is now charged body. So this proves, yes, this body is charged. Okay, so now if there is no charge, I brought something, a plastic, it can be plastic, it can be a neutral body where there is no charge. So for that, what we need to do? So there is no charge. So if basically there is no charge, there is no charge, no charge. So no charge means this. So here if there is no charge, then these two will not repel. They will be in their basic positions. They will be attached to each other, not repelling to each other. Okay. This proves that this is not charged. If the aluminium foils will not repel, they will be there in their original position. That proves that the object that I brought it and touched to the metal, that object is not charged. Okay. So this is clear. So electroscope is the instrument which shows that whether an object carries any charge or not. Hmm. Now we also can understand whether they are bringing the whether it's a positive charge or negative charge, it will be same. If it is positive charge, then these two aluminium foil also will be positively charged, and as we know, the similar charges, the like charges repel, so it will repel. Now suppose they are the negative charge, similarly this part will be the positive and these two aluminium foil will be the negatively charged. Again the similar or the like charges will repel. So whether this object is positive or negative, in both the cases, these two foil will repel. That means this object contains the electric charge. Clear? All right. So now we are moving to the next one. I hope how to make it. You can practice the diagram. Here we have seen the earthing. We will be talking about this in the next topic. Now, electricities can be of two types, static and the current flow. When the electric charge is not flowing from one object to another, as you have seen that the pieces of the paper and my comb. So what was happening? The charged body, that is the comb, was attracting the piece of paper to it. Okay. So here the electron is not flowing. It's static either in the comb or in the pieces of the paper. Or if I take this cloth, the silk cloth and the balloons, in there also when I'm doing the friction is causing the balloon, the surface of the balloon to be heated, and when that is heated, the electron is moving from the cloth to the balloon, so that it is being electric charge and the cloth is being positive charge. They are static there. Those electrons are not moving freely. And when does it happen? When we are doing it with an insulator or which is not a good conductor. I hope you are aligned with the term conductor and insulator. That if you have not, please see the last video. Right? There we have seen that the object, the metal, so through which the electricity or the charge passes easily, those are called conductor. And those objects like the wood, plastic, glass, they don't allow the electricity to pass through it, the current pass through it. They are called the insulator. Okay, so here the electroscope, from the electroscope we have done that this is the device. We have seen that any object, whether it's charged or not, that can be proved, that can be seen and detected, right? Now coming to the grounding, or we call it as earthing. You can see the transfer of the charge from an object to the earth. So what is happening basically? Suppose this is a charged body. Okay, this is a charged body. I am holding it. I am touching it through my finger, through my body, because I am a conductor here, and I'm standing on the ground barefoot. No rubber sandal, no slippers, no shoes. So without the sandals, slippers, and shoes, directly this charge is passing through me and going to the ground. Right? The charge is going to the ground, and in the that our earth, it is also a big magnet because it has the charge of generally the opposite charge. That's why it is attracting us and we are able to walk on it, isn't it? We are jumping and coming back. We know that is a gravitational force. So it has also the charge and probably the opposite charge, which will attract and gain all kind of energy and charges, whether it's positive or negative. So when the charged body, and in the charged body I'm touching, through me the charge is passing to the ground, this which is called the grounding, or we can call it earthing. So all the wires that we have at our home, we have the switches, right? The switch, generally there are the 3 points. I hope you have observed there are the 3 points. One is for the positive wire, one is for the negative wire, and the third point, the third in the socket, the third hole is for earthing. That earthing, that wire directly goes to ground. Now why it's important? It's very important because whenever the excess current passes through it, otherwise it will be spark, there will be an explosion. To avoid the explosion, to avoid the accident, the third wire will be grounded, so that whatever extra charges are there, that extra charges will be grounded for the safety measure. Clear? That's why we check whenever we are going to a new house or a very old house, we check the earthing. We say that earthing is proper, right? Have you checked the earthing? If not, we have to, if maybe after very old ancient houses, okay, grandparents' houses and great grandparents' houses. So in those cases, maybe the wire that is going down from connecting all the electric wires, that may be torn or that may be disrupted. Okay, so we have to check whether the proper earthing is happening or not for our own safety, so that any reason, if any charges are extra or extra current is passes through it, that excess charge will be grounded. Okay, this is clear. Now we are moving to a very interesting topic, that is the lightning. What is lightning? I said the next topic is lightning. As we hear the term, we can understand that which season we can see the lightning. Yeah, is it summer, winter, or monsoon? Yes, it's during the rainy season where we can see the clouds in the sky, lightning, thunder, thunderstorm, etc. Right? So now we are moving to lightning, and we can see the black clouds during the monsoon season because the clouds are heavy with the water droplets in it. We know the water cycle, so the water gets evaporated and condensed in the clouds. So when the amount of the electric or water droplets are, very heavy, very high, there are the charges also accumulated. Now, who told this about? Benjamin Franklin, the scientist who's actually who was a businessman and whose picture you can see in the dollar. So that person said that I can imagine, or I can think that what I believe, that those clouds and those thunders, they have the charge in it. To prove that, what he did, he took a kite, and the threads and all that is needed, he put the metallic objects in it to attract the lightning. What is lightning? We are coming soon. So as you see the spark in the clouds, in between the clouds, and that spark, the lightning, that is called the lightning, right? It comes sometimes with the sound. That sound is after some time, that already the lightning is done, and after some time we can hear the sound. And as you know, the light travels faster than the sound, right? The sound wave. So the light we see first, and then we can hear the sound, and it is like a precautions. It is around 10 miles of. That means if you hear a thunder sound, that means the lightning is also happened nearby. So be cautious, have some precautions, and run to a safer place. Okay, yeah. So Benjamin Franklin, he put some metallic wire and all in the thread of the kite, and he was flying the kite, and he was trying to get that charge from the cloud. But it was not the lightning directly on the kite, luckily, but yes, he could got some shock or the spark. Okay, he tried to capture the lightning in a glass jar, but he could understand, and from that time, and after Franklin, there are a few more scientists to prove that yes, those clouds are, and the sparkling and the lightning, those are all charged. The spark, actually, basically what we see, that when we are touching a socket with our weight hand, we get electric shock, isn't it? Or when we are putting our mobile charger to the socket and we are taking it out without switching off, which is very dangerous, there also we can see sometimes the spark, right? Yes, so those spark in a bigger amount, in a larger amount, we call it lightning. Now here what is happening, these are the clouds, I'm doing with the cursor right here in the in this, and here are the land. This is the land. In the land also we have trees, we have tall buildings. So those trees, tall buildings, those are the more prone to get the lightning, the more height. So here is small benches, parks and all, and those with the height, those with the towers, big towers and all, those are more prone to get all the charge. So here what happens, top part of the clouds, they are all positively charged. So above part are all positively charged, and the lower part of the clouds are all negatively charged. So these parts are negative. This is done after many experiments and many saying. And this top part is also the opposite charge. These are all plus charge. Okay. And negative charge in the bottom. So when the above part is the plus charge, you can see the opposite charge. In the middle, there are the air. Air is this air. We will write this is air. And air is a poor this is insulator actually. So as it is insulator, so this is air. And air is poor conductor, or we can see it's a poor conductor of electricity. So air is the poor conductor of electricity. It doesn't allow the charges from the clouds and the charges from the ground or the earth to meet with each other. But sometimes when the charges accumulates, the charges become heavy, that the clouds are also not able to support anymore, like the water droplets. What happens? The droplets come out as in the form of the rain, isn't it? It comes out as in the form of the rain. So, okay, so these are the rain droplets. So rain, and with the rain droplets, obviously it is charged. The charged particles are also getting down. At the same time, I will take this as this. These are the air currents. The air currents from the ground, it's moving to the up. Okay, because we know what happens when the ground gets heated, that heat goes up because the light air moves up, and there is the vacuum created. So from the surrounding, the cooler air will come to fill the place. So this is basically the air current. Okay, so let me write, this is the air current, and these are the water droplets, or yeah, these are the water droplets. So with these are all water droplets. Water droplets. So these are all charged. Air current and water droplets are passing, is a crossing. These are, one is going upward direction, the air current is going upward direction, and the water droplets are falling downward direction. In this, the air, which is a poor conductor, also cannot protect or cannot prevent the charges to meet with each other. So what happens, basically the minus, the negative charges and the positive charges, they both gets interchanged. I mean, there is a transfer of the charges, and this transfer of the charges cause the sparkling. And this also can happen, it's not only with the ground and the clouds, it can also happen in between the clouds. So here also it can happen in between. We can see the lightning. Okay, we can see the lightning here, or we can see the lightning here, mainly on the top of the tall buildings and this trees and all. The tall objects, the more tall the objects, the more prone is the lightning will occur on this. Okay, so I hope this part is clear. So the clouds are heavy with the water droplets. The above part of the clouds are positive charge, and the lower parts are negative charge. Oppositely, on the ground also, the tall objects are all positively charged and the lower are all negatively charged. In between, there is the air, which is the poor conductor of the current or electricity. So it won't allow, but up to a certain time. So when there is the heavy accumulations of the charges, the clouds cannot hold it anymore, as the water droplets will come down as the downpour, or we can call it as raindrops, and the air current will going to the upwards, and there is an interaction, and the air cannot hold them. So there is a meeting of the positive charge and the negative charge. There will be the sparkling, so which cause the sparkling to occur. Clear? All right. So lightning is clear. Now let me share. So this is what I have drawn here: the clouds, the air current, the water droplets, and basically which is causing the lightning. Now light and sound appears when there is the electric charge transfer, and that's why we can hear the sound as thunder and the lightning. So thunder and lightning is clear, I hope. Now we have to have some safety measures for that. That is basically the electric discharge and what is happening, it's clear. Now what are the safety measures? How can we protect ourselves? So as I said, the tall building, the tall objects, when you are outside, when you are indoor and you can hear the thunderstorm or you can get a precautionary measure, I mean, you got the information, so it's going to happen, the weather forecast, the meteorologist already tried to inform it earlier that today or tomorrow, the weather condition is this, the wind will run in this mile per hour and there might be the thunderstorm, so stay indoor. That is the first thing. Now you are very emergency, you have to go out. When you are outside, when you're outdoor, then find a safer place, and that is always indoor, not in any park bench, or in any vehicle. Even the vehicles are made up of the metal objects, and you know the metals are the good conductor, so the lightning will be attracted by the metal and it will be passing through it. When you are in a public transport, maybe in the bus or any other motorbike, or motor car, any other vehicles, so tell the driver or drive to a safer place and then you wait inside, don't come out. Okay, and if you are outside, then try to move towards the ground, because the more you are towards the ground, then you are safer than you are moving up to a taller building or a tree. And when we are indoor, that time also we need to avoid in touching any metal pipes or electric wires. We say that switch off the TV, switch off the refrigerator. I hope you heard this, because you know the sockets are there. Maybe the electric charge will come and they will disrupt all the electric circuits in the present in the house. Maybe the grounding or the earthing is whether it's okay or not, we are not sure. So it said that remove, unplug the wires from the switchboards and don't touch any electrical appliances and avoid using that. Okay, so we can do that. Now in many tall buildings, so in Hyderabad, in Bangalore, in Mumbai, Kolkata, in many places, not only India, I'm talking about outside, there can be in Dubai, in other Singapore or other countries or other cities, we see tall building, high risers. So high risers, the more high rise the building, the more prone it's to catch the lightning. So most of the houses, buildings, they have a lightning conductor, that is the lightning rod at the top of the terrace. What is the use of it? You can see sometimes there is a light. That is another reason the flyers or the airplanes and others, they must see that yeah, there is a tall tower or a building, and also the lightning rod will catch the electric charges because it will be coming to that rod, and through this wire it is being grounded or earth. So earthening, we have done it before, covered it before. There will be a metal wire, it can be copper, the cheapest one. With that copper metal, the charge will directly be grounded, so the house, the building, the people, all are safe. Okay, so that is about lightning conductor. Before moving to our next topic, which is the earthquake, another natural phenomena, I hope lightning, thunder, and the charges we have discussed about electroscope, these are clear. Yes, so we are moving to earthquake now. What is the reason of the earthquake? Okay, so generally what we see that the the ground is shaking, so we call it as an earthquake. It can be the life threatening, the many death and other casualties may appear. There can be the crack in the wall, there can be the crack on the ground, the field, so it is difficult for the agriculture purpose, or if the building is not what earthquake proof. The Japan and other country which is very much prone to earthquake, even every day they feel the earthquake. Those houses, you cannot see the tall risers or high risers, but they are made up of in such a material, it's not like our cement and all, so that is earthquake proof. So there will be less crack and it is less chance to get demolished. Okay, so That is first thing that we have to find out, that in our world which are the earthquake prone area. So there we have to be, the people staying there, they already know that we are in the earthquake prone area. So what measure to take the precautions to save our life, so they know that. Well, now coming to what causes the earthquake. What causes the earthquake? Basically here, object. Now what we are talking about, the different layers of the earth. So this is the earth first layer. Now we are moving to, why the color options is not there. Suppose I want another color. Okay, okay, okay. So here, if I have to feel the outermost layer, this is the earth crust. The earth crust is the outermost layer which is made up of many plates. Okay, these plates we can call them as tectonic plates. So this is the earth crust where we are staying, where we are living. The houses, buildings, the roads, these are all in the earth crust. All right. The second layer is mantle. The mantle, there are so many metals, and the temperature is also high. So this is the, so let me take it mental as mantle. This is the this is the mantle. The mantle, there is the liquid part as well as the solid part. So it is basically the viscous, the liquid plus solid, the temperature is high. This is the second part, mantle. Then we have outer core and the inner core. So this is the outer core, and the last part we will take it as red. This is the inner core. So we know the inner core is the most hottest part, then the outer core. The more it is coming outwards, it is becoming the less hot, right? The crust part, as we can stand, as we can move. So let me write now which part is what. So this is crust, this is mantle, this is outer core, and this part is the inner core. So this is crust. This part is mantle, mantle. This is outer core, and this is inner core. Okay. Now crust is the outside part which is made up of many plates. I said mantle is semi-liquid and solid. Mantle, the temperature is more, so basically it's on the liquid part. Outer core is also liquid. So, and the inner core is the hottest part. Few metals like nickel, copper, these are seen in the outer core and mantle, because in the inner core nothing is in the solid form, all are liquefied. Now here you see these two part, mantle, outer core, these are, we can call it liquid part. And on this liquid part, this crust which is solid plates, these solid plates are actually in the viscous or liquid. So what basically is happening, this is all liquid. Okay, just imagine this is liquid, and on the liquid few plates are moving, few plates are there, few plates are moving. So the plates are there on a liquid, the plates cannot be fixed in a position. Now got it? What is happening? The plates cannot be fixed in a positions, isn't it? They are actually floating on the liquid. So when they are floating on the liquid, they will dash with each other sometimes. Now you can understand, they are dashing with each other. So they will dash with each other. So when they dash with each other, that causes the earthquake. It can be side dashing to each other. One is moving this side, the another one is moving this side. One is moving down, another one is going up. So one will be downward, one will be outward. So on one plate, another plate is there. So different kind of movement, dashing can happen, and these causes the tremor. This causes the earthquake. So here will be the crack, here will be the crack, here will be the crack, and it can happen, the deep inside the ocean, which is causing the tsunami. So earthquake deep inside, when there is the epicenter we call it, right? In 2004, you remember, in December 26, there was the earthquake which causes the tsunami. Okay, in Indonesia, Java, even Andaman Nicobar, and we all feel the tremor because the earthquake was more than 7.5 magnitude in the Richter scale. So next we'll move to the earthquake and how to measure it and all. So earthquake, the reason behind it is clear. The layers of the earth. So here we have seen these are the layers of earth, and in this we have understood that there are the four layers which causes the outermost layer or the crust to basically float on the mantle and outer core, and this is the liquid, the solid on the liquid, the solid plates, the tectonic plates will be dashing to each other because they are not fixed, they are moving towards each other or to away, and they may cause this earthquake. This is the reason for earthquake. Here, this part is clear. Now we are moving to the next one. The result of earthquake, that can, as I said, that landslides, it cause flood, it cause tsunamis. The damage and the massacre is havoc. Okay, the dam, the bridge, these all can be destroyed. So as I said about the major tsunami, whose magnitude was 7.5 in the Richter scale. So Richter scale is actually the measuring device for the magnitude of the earthquake. It can be from the Richter scale, the measurement is from 0 to 10. So 0 to 6, we can call it the moderate earthquake. It's hardly felt, so it's all fine, no casualties. But more than 6, it's a, yes, that you can feel, and not only feeling, we can see the cracks and all. If it is beyond 7.5, it's a massacre. Okay, it's this tremor is really something serious concern about. Now, what are the seismic waves? They are how to measure, like what is the magnitude of it. The tremors actually, there is, I'll show you the picture. So basically what happens, there there is a device that has a needle with it, and there is a roll of paper. Okay, so as it moves, as the earthquake is there, it moves, the needle moves, and it creates this kind of magnitude in this. Okay, so this is actually the seismic wave. The wave produced by this, we call it the seismic wave. This needle actually will create the wave. However, this earthquake is happening, they will move up and down, and these are called the seismic wave. These are called the seismic wave, and the device in which the waves are recorded, that recording instrument we call it as seismograph. Right? So seismograph, seismic wave, earthquake. These topics are clear. Shall we move to the next? So the safety measures from the earthquake, both the indoor and the outdoor. In the indoor, when you are inside the house, try to get shelter under a table or a big tabletop, so that anything happens, your head will be saved. The head is the main part of our body. If the brain or the head is damaged, then the body is dead. So what we have to do, we have to cover our head. If you have helmet, wear it. If you can sit under the table, do it, so that any casualties, any damage, you are protected. Your head is protected. Don't try to get up. Okay, try to avoid the lifts and all. We know that we have to, if you are coming out and all, try to avoid the lifts and have the staircases. When you are outdoor, avoid from the tall trees and drop to the ground. So, because as you know, the tall building, tall and metallic pole and all, these are all can be electrified. And if the electricity is there, the building will fall on you if you are near a building or a tree. So, avoid those things and be grounded. So we are almost done. There are some other measures that you can go through it. So a quick recap of what we have done today. Hope you have understood, right? In the recap part, a mind map, we have covered the topic like current, electricity is done. So we have started with the structure of atom. So in an atom, we have the positive charge, we have the negative charge, and also we have the neutral charge that we have seen. Then we have seen that the like charges and the unlike charges, like unlike charges, we have covered electroscope, how to create an electroscope at home, and what is the use of electroscope to detect the minute presence of the electricity or the charge in any object. After electroscope, then we have moved to the like charges will repel to each other and the opposite charges will attract to each other. We move to lightning. What is the reason behind this natural phenomena of lightning, about the clouds and air currents, and how these water currents and the air currents will cause the interchange, the electric discharge of the charges, and that cause the lightning. This is the more larger version of the sparkling that we can see. We move to earthquake. So what is the reason for the earthquake? We know the structure, the layers of the earth, and why these plates will be on each other. So I hope you like the sessions and today you have learned something new. Always share your knowledge. Any part of the video, if you enjoyed, you liked, please click on the like button. Don't forget to share and subscribe this channel with your near and dear ones. So take good care. Thank you very much. Stay tuned for more videos.